Hello students, welcome to Babbar's Academy. Today I am going to teach you about Moleconcept and Stoichimetry part 2. In last video I told you about Gay-Lussac's law. Now I'll do some numericals regarding this law. First numerical is what volume of oxygen is required to burn completely when 200 ml of acetylene or acetylene, that is C2H4, and what would be the volume of carbon dioxide formed. Now, what is the question? What volume of oxygen is required to burn completely 200 ml of acetylene C2H4, and what would be the volume of carbon dioxide formed? First we will write equation for this. Equation will be, the equation is regarding C2H4 plus oxygen. What will form? Carbon dioxide and water. As I have already told you, first you have to balance the equation. First step is. Now, while balancing, we will check 2C2H4, 5 watt oxygen, and it will come 4 carbon dioxide, and it will 2 will be here. That means 2 volume of acetylene, 5 volumes of oxygen, 4 volume of carbon dioxide, and 2 volume of water. That means 2 volume of acetylene reacts with 5 volume of oxygen to produce 4 volume of carbon dioxide and 2 volume of water. Now, what to find? What volume of oxygen is required? जो चीज आपको चाहिए वो आपने राइट साइड पे लिख लेनी है. And what else is given? 200 ml of acetylene C2H4. And what will be the volume of carbon dioxide formed? Now here there are two parts of the question. First is C2H4 right here. 2 volume of acetylene reacts with 5 volume of oxygen. That means 2 volume of acetylene are required for reacts with 5 volume of oxygen, and 1 volume of acetylene will react with 5/2 volumes of oxygen. What is next? We have to find 200 ml of acetylene. If reacts with oxygen, what will happen? 200 ml means volume is 200, then it will be 5/2 into 200. That means it is 500 ml. This is the first part. Or as we have seen, if 2 volume of acetylene reacts, 5 volume of oxygen is produced. That means 500 ml of oxygen produced. This is the first answer. Now second part is, what would be the volume of carbon dioxide formed? Again we will see that if 2 volume of acetylene reacts, it gives 5 volumes of oxygen, reacts with 5 volume of oxygen, and 2 volume of acetylene it will form 4 volume of carbon dioxide. That means we can simply write 200 ml of acetylene will form carbon dioxide is equal to 400 ml. Because 200 is equal to 2 volume is equal to 200 ml, 5 volume is equal to 500 ml, and 4 volume is equal to 400 ml. In this way we can calculate this equation. Now what is next? Example number 2 is, if 6 liters of hydrogen and 5.6 liters of chlorine are mixed, as it is according to the Gay-Lussac law, gases are mixed and exploded, that means burnt. What will be the volume of a resulting gaseous mixture? Hydrogen, 6 liters of hydrogen and 5.6 liters of chlorine. Again we have to write the next question. This is again we have to write the equation for this. Hydrogen plus chlorine, it forms 2HCl. This is the balanced equation. That means 1 volume of hydrogen react with 1 volume of chlorine to produce 2 volume of HCl. Now in the equation it is given 5.6 liters, volume is in liters, 5.6. That means we can also write 1, as we say 1 volume is equal to 1 liter. We can write it like this, or we can also give it 100 centimeter cube. 5.6 volume is equal to 5.6 liters, it is liter. 5.6 liters of hydrogen reacts with 5.6 liter of chlorine to form 2 volume. That means 2 into 5.6, this is equal to 11.2. That means HCl produced will be 11.2. Now the resulting mixture will be, hydrogen is 6 liter. It is given 5.6 liters is consumed and remaining 0.4 liters is balanced. And in the same way we can calculate HCl. This is 11.2 liter. It is production. Hydrogen HCl is 11.2 liter it is produced and hydrogen left is 0.4. इसका मतलब ये हुआ कि जो रिजल्टिंग मिक्सचर है उसमें 0.4 लीटर हाइड्रोजन बची और HCl जो है वो 11.2 लीटर्स है. This was the second question. अब now we come to third numerical. In the third numerical we see what volume of propane is burnt for every 100 centimeter cube of oxygen in the reaction. First we have to write the equation C2H8 plus, write the balanced equation 3CO2 plus 4H2O. According to this, this is 1 volume, 5 volume, 3 volume and 4 volume. Again, what is to calculate? What volume of propane? That means we have to find out propane. Write propane to this side. And for every 100 centimeter cube of oxygen, write oxygen here. Now the comparison is of oxygen and propane. what volume of propane is burnt for every 100 centimeter cube. So here we see 5 volume of oxygen is required for 1 volume of propane, and 1 volume of oxygen is required for 1/5 volume of propane, and it is given 100 centimeter cube of oxygen. For it is 1/5 into 100, it is 20. That means 20 centimeter cube of propane is required for this much of oxygen. Now question number 4. 80 centimeter cube of methane is mixed with 200 centimeter cube of pure oxygen, and mixture is ignited. Calculate the composition of resulting mixture. Again, equation is CH4. You can write the conditions also. What is the state of the element? 2O2, CO2. This is again gaseous. 2 water. This is liquid, and this is gaseous. I'll tell you why we have written the gaseous and liquid form. This is 1 volume. Again 2 volume, 1 volume, and 2 volume of water. As this is the equation of gases, law is a mixing of gases, we will write this as nil. Water is negligible, it is not taken. Only the gases are taken. Now how we will do? Because we know this is a mixing of gases, so by Gay-Lussac law, we know that when combustion takes place, this is the reactants are before combustion and products are after combustion. So before combustion, what is there? Before combustion, 1 volume of methane, as the equation shows, 1 volume of methane, and it gives 2 volume of oxygen. And in the same way, we have 80 centimeter cube. So much of methane give 2 into 80 is equal to 1 centimeter cube of oxygen. And after combustion, we will see 1 volume of methane produces. After combustion, it will produce 1 volume of carbon dioxide. And in the same way, 80 volume of methane will produce 80 centimeter cube. So we have to tell what is the composition of the reaction, composition of the gaseous mixture after reaction. So this is methane is 80 minus 80 is equal to 0. Carbon dioxide 80 centimeter cube, and oxygen is 200 minus 160 40. It is 40 centimeter cube, and water is nil. It is negligible. This is all I have told you about the numericals. Now if you like my video, don't forget to comment and share it. Please subscribe my channel. That's all.